I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 27th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we have good news. There is a broad gale, actually it was a storm, but now producing 42-foot seas over the northern dateline region and lesser seas in the 30-plus foot range over a broad swath of the North Pacific, all aimed off to the east, and that is producing swell radiating towards Hawaii and the U.S. West Coast. And even before that, there's remnants of a small gale off the U.S. West Coast, still producing 20-foot seas, and that swell is impacting the coast as we speak. So, things are starting off pretty good. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough that is a dip in the jet, just like that right here. That helps create a counterclockwise flow aloft and also down at the surface, and that is the hallmark of low pressure. If low pressure is deep enough, it generates winds. If the winds are strong enough, they generate seas. If the seas are high enough, as they radiate away from the fetch area, they turn into swell. And swell, of course, when it hits your beach, turns into surf. All right, so we have a good consolidated jet stream flow here with 170 knot winds pushing off Japan, falling into a trough, generating, as we already know, some sort of a gale pattern over the northern dateline region, then ridging a little bit, but not splitting, and then falling again into a secondary trough that is supporting low pressure off the U.S. West Coast that again has also generated swell radiating into the coast. So we're starting out with a pretty optimistic looking pattern. As we put this into motion on Monday, more of the same continues with the trough holding in the northwestern Gulf of Alaska while the trough off the U.S. West Coast moves onshore, likely setting up some weather. As we continue on into Tuesday or so, we see the jet trying to split a little bit while wind energy builds off Japan to 190 knots. And notice this, we got two little troughs here as we get into Wednesday, and then a broader trough trying to set up. It's not in the Pacific yet, but trying to organize. Notice this trough on Wednesday, Thursday pushes off to the northeast, of course, supportive of gale development with, 160 knot winds feeding into it, while the 190 knot wind trough off Japan builds and pushes east. And as we get into Saturday, the jet fully consolidated with winds to 170 knots, pushing the whole way across the Pacific. Given the MJO situation, the La Nina situation, this was not expected, but we're taking it. This is all good news. Where are we at? We're out at Sunday now, a week out, and the jet still holding as we get even into Monday, though with much less wind energy in it and no real obvious troughs, just what they call a zonal flow. The jet running flat west to east from Japan right on we'll say about the 38 north latitude line, the whole way into Northern California. Looks like a setup for some precipitation, maybe over the long haul, and California can take every drop it can get. All right, let's move on. Surface level pressure and surface level winds. No big surprise here. A broad gale with 45 knot winds is set up on the northern dateline region. The dateline right there at 180. So this is the northern dateline region. We'll say the southern dateline region would be more down here. But fetch covering the whole area from 35, 40, 45 knots over a broad, just filling almost the North Pacific other than the Gulf of Alaska. And then there's our little fetch off the California coast. As we get into Monday, the gale starts fading with 35, maybe 40 knot winds over the North Dateline region, and then fading out. But on Tuesday, this is the system to watch. A new, small, little thing approaches the dateline Tuesday morning, and by Tuesday evening, you can't really see it, the tags here, 984 millibars, but 55 knot winds, maybe greater, developing, pushing over the dateline straight to the east. There you go. You can almost see it, 60 to 65 knot winds. That's hurricane force there on late Tuesday night, early Wednesday morning, continuing to lift to the northeast. Still 60 knot winds as we get into Wednesday, fading to 55 knots, and then 50 late Wednesday night, but still 45 knots as we get into Thursday, while yet another system builds behind that. I mean, the Pacific just turns into a wave-making machine. This first gale continues even as we get into Friday. Right there's Friday morning with 40 knot winds off the California coast. Broad area fetch now moving into the Bering Sea, but some continuous bits of wind energy, the whole westerly winds the whole way from Japan in pockets here, and here at 30 to 35 knots. There will be swell that will result from that if that materializes. And then we know another trough is going to try and set up with, look at this, another gale here on Well, let's go right to Saturday morning. A gale in the northern Gulf, another gale over the northern dateline region with 45 knot winds, building to 50 knots later Saturday. Now, not as broad, but still, here's again one of these large swaths of 30 to 35 knot fetch going over the northern dateline region and into the eastern Gulf of Alaska. And it just keeps going. I mean, quite amazing there. We suspect the pattern will probably mellow out a week from now, but still, there is much surf, it appears, in the forecast. Let's go look at the effect of those winds on the ocean surface. Now, we're going back in time just a little bit to Friday night, early Saturday morning. This is a day ago. Gale in the Gulf of Alaska with 20, 22, 23-foot seas, let's say. And then the broader gale, this is the one that's set up over the northern dateline region. We'll just watch that evolve with seas into the 36, 37-foot range, building to 45 feet on Saturday midday, pushing 52 feet on Saturday evening, and 53 feet in the evening again, then starting to fade out on Sunday morning with 48-foot seas, while this system off the coast is generating more swell that is radiating towards California. In fact, we can go one more frame there, and notice this little pocket down here of 19-foot seas well to the south, aimed well at Southern California, so they should also get into the action here. Much of the storm track has been to the north, sort of shadowed by Point Conception relative to Southern California, but now it looks like something clearly in the swell window relative to Southern California. So now we move forward into Sunday evening, and look at this. The gale supposedly redevelops just off a little north of Point Conception with 22-foot seas, falling southeast 23-foot seas, and never mind the fact that there's this massive area of 20, 22, 24, 26, 28 to 30-foot seas just filling the North Pacific on Monday morning. This gale and low, whatever you want to call it, 21-foot seas very close to Southern California. Could make for some surf if you are in the right place, but probably some weather too. Anyway, as we get into later Monday, the gale over the North Dateline region starts fading, and you go, oh, that's not good, but here comes our next system, and this is a strong one indeed. As we get into Tuesday evening, small area of, 42-foot seas developing, targeting pretty well at Hawaii, but the track is going to sweep off to the northeast, so most of the energy, we'll say, is going to bypass Hawaii, and the target is big and fat right in here. So we get into Wednesday, seas start building from 46 feet to 53 feet, and then Wednesday evening, 59-foot seas forecast, almost 60 feet. That is some solid, serious swell-producing potential there. A lot of period and relatively close. Now, you see Hawaii here. Yes, sideband energy for the Hawaiian Islands, but most of the energy is targeting right up in here. All right, as we get into Thursday, the system starts fading, relatively speaking, but still 48-foot seas, right smack in the western Gulf of Alaska on Thursday, fading to 45 feet Thursday evening. Jeez, this just goes on. Friday morning, still 39-foot seas. Probably this is looking like almost too much swell, tow-in only type situation, but we'll see. And then behind that, so we'll just go back to the dateline. Another smaller system develops on Saturday with 45-foot seas. This is just quite impressive. And you see 34. We'll just sort of roll through this. Again, broad swath of 20-foot plus seas as we get a week out. Now, again, do we believe a model a week out? No, but you know what? The models have been pretty solid concerning all this. If anything, they've upgraded a little bit this evening, which only says, well, you know, it only increases the probability that all this is going to happen. So keep your eyes on this. Wind situation. All right, so surface level pressure, surface level winds zoomed in on California and Hawaii. Sunday, trades, 15, maybe 20 knots for Hawaii, not so bad. There was a little window of light winds in the Northern California region today, midday, but winds have started picking up south now at sunset as the low approaches the coast. Looked like a wall of rain building right off the coast. As we get into Monday morning, north winds, maybe a little bit of northeast into Northern California, Central California looks like, and even into Southern California, probably a west wind event, and trades for the Hawaiian Islands, 15 knots. As we get into the evening, the low moves over Southern California. It shows a relatively hole here of 10-knot northwest winds for Northern California and 15 knots down here. That's probably a little bit optimistic. Trades lighten up for Hawaii. So we get into Tuesday. The wind, a little bit of high pressure, tries to take root here relative to California. Unsure, but probably northwest winds, 10-15 knot range all day. Trades continue for the Hawaiian Islands. As we get into Wednesday, winds back off along north and central California in the 5-knot range as an approaching low pressure system sets up off of Oregon. Trades relatively light for the Hawaiian Islands. Now look at this. You can start to examine this low that's building out here, and you can see right there, that's the 50, this is 55 knots, so this is 60 to 65 knots right in that little window there, but we will not get distracted. So we get into Thursday. Looks like kind of strongish northwest winds for California. Trades light for Hawaii. But those winds, they pretty much hold for California on Thursday. Doesn't look so good. Moderate high pressure driving trades, 15 to 20 knots for the Hawaiian Islands. Friday, again, one of these little windows where the winds just die along the California coast. Trades strong, though, for Hawaii, 20 knots, and holding solid. You see that there. And then that's into Friday night. As we get into Saturday, maybe a little bit of south winds up here into North California, but light winds for Central California. Strong trades holding early, at least for Hawaii. Looks like all day. And then it looks like another south wind event setting up for North and Central California as we get into Sunday. And then lightening up later on Sunday. So let's go back and take one quick look at that. Yeah, so it was Saturday night was the south wind event, and then Sunday, winds fading through the day. Trades continue for the Hawaiian Islands, but a little bit weaker, 15 to 20 knots. So windows of opportunities for California, but not, just a perfect offshore pattern every day. So you got to sort of pick and choose where you can go and gauging swell size as well. Precipitation forecast for California. So here we are. This is roughly sunset on Sunday. You can see the rain building in to California, Central California. The Golden Gate is right there. And snow for the Sierra from Tahoe. Tahoe's right at the crux of the bend there. So Tahoe southward, Monday, not a lot of snow, but continuing Monday, clearing eventually for Central California. But look at this, also precipitation all day through the day for Southern California. That is a very good sign. Then things clear out. We have nothing happening until we get into maybe Wednesday night or Thursday. Snow for the Sierra, rain for Thursday morning for North and most of Central California. Clearing out as the day continues, snow fading out. Another one behind that, pushing in maybe Friday night for Northern California, making it to the Golden Gate right there, midday Saturday, but no further south. And then back building into Sunday with a pretty healthy snow event, it looks like maybe for the Tahoe region on the day, through the day, Sunday, and then starting to fade on Monday. Let's go take a look at some snowfall totals. Squaw Valley for the week, we're going to put this at about 34 inches, but notice this goes out 10 days. Highly unreliable, but some magnanimous amounts of snowfall possible. We would like to believe that that is true because that only does good things for the water table and the reservoirs and all that. Freezing levels, not bad. This is for Squaw Valley. This is the top of Squaw at 9,000 feet, like the top of Granite Chief Peak. Yeah, one little blip of above freezing temperatures, but for the most part, freezing level, in worst case scenarios, just above the base except for there, and maybe a little blip there and there, so not so bad. Wind levels. Now here is a bit of a concern. There is December 31st, gust 80 knots. January 3rd up into the 90 knot range, and again on January 5th later in the afternoon. Let's go take a look at Kirkwood. Much the same, maybe not quite as much, 24 inches, and then building because they're a little bit further south, and sometimes these systems just a little wobble in their track can make a big difference in the snowfall amounts. The good news is Kirkwood is higher, so basically frozen. The whole window, this is the base, this is the top of Kirkwood, other than one little window there on January 1st. Winds, still an issue, 80 knots, 75 knots in pieces. Let's go take a look at Mammoth, too. Being further south doesn't help as much, maybe 8 inches of snow until you get into this maybe supposed blip 10 days out, so we're going to just sort of ignore that for now. Here's the base of Mammoth, much higher at 8,000 feet. The top at 11,000 feet. So good, pretty good cool temperatures, at least good for snowmaking if nothing else. Winds, not as stormy a pattern. Yeah, 60 knot gusts there on January 1st, but otherwise probably in a reasonable range. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and the El Nino Southern Oscillation? And when we say long term, we're talking anywhere from 2 or 3 weeks out to maybe a year out. So a lot of this, take it with a grain of salt, but we're doing our best to try to get a handle on the long-term outlook. So first off, we're looking for the presence of the active phase of the MJO, the Madden-Julian Oscillation. All right, and what the MJO is, it has 2 phases, an active phase and an inactive phase, polar opposites to each other. What we want to see is the active phase of the MJO cross the Pacific. And when it does that, the active phase basically is a low pressure system. And when it's moving over the West Pacific and the Dateline region, what we call the Kelvin wave generation area, what it does is it tends to reverse trades in that area. That can produce a Kelvin wave that is short, basically warm water that's stored in the West Pacific starts sloshing to the east, forms a ball that travels under the equator from west to east. Okay, and that can help kick off El Nino. But what it also does is it reduces trades, and that imparts energy to the jet stream, and that in turn feeds the storm track. All right, so what are we looking at here? Data from the TAO buoy array, the top chart here. This is the East Pacific here. This is the West Pacific here. There's buoy. This is the equator right here. Okay, that's New Guinea there. The date line, 180 west right there. Okay, so we're looking at the arrows. These are 5-day average winds. The longer the arrow, the stronger the winds. No surprise. Strong east trades in the East Pacific, continuing over the Central Pacific, and raging east winds over the Kelvin wave generation area. So that is not a symptom of the active phase of the MJO. It's basically the exact opposite, the inactive phase of the MJO. But it's not actual winds that matter. It's the anomalies, the difference from normal for this time of year. What we see here, looking at this chart, lower one here, is that, well, yeah, winds are strong here out of the east, but they're always strong this time of year there, so this is no big deal. Same in the Central Pacific. It's only when we get into the Kelvin wave generation area from 135 east to 170 west, 5 degrees north and south of the equator. So you draw a box in your mind here. And when you see these strong east anomalies, that does not support energy transfer into the jet stream, at least per the standard model that we've been typically using. But clearly, looking at the models, you can see a very active jet stream and a very active storm track. So whatever's going on here doesn't seem to be coupled with the jet stream at all. And for our purposes, that's great news because we're getting surf and we're going to get rain, and it doesn't even appear that the active phase is in play. So that is good news. Next up, we look at the forecast for winds in the Kelvin wave generation area, the West Pacific. That's the important area for, one, not only generate Kelvin waves, but also, two, for feeding energy to the jet stream, assuming it's all correlated. All right, so the date line, this is the whole planet on one chart. This is time here. We go back to November 27th up to 1 week into the future to January 3rd. The date line right here. Okay, Kelvin wave generation area starts about 135 east, so right here you go right up there in your mind's eye to about 170 west, right there. You can see the purples and the blues are easterly anomalies, like the inactive phase of the MJ. And you can see we've been through a window here of not much, yes, easterly anomalies, but not real strong. All the westerly anomalies are in the Indian Ocean. So if this were over the dateline region, we'd be very excited. When we see the easterly anomalies over the dateline region, that typically does not support energy transport into the jet stream. And look at the forecast here for the next week. Raging strong east anomalies in control. Looks like the inactive phase of the MJO, or when you see these long stretches of easterly anomalies, that typically means La Nina. And of course, we all know that's where we are right now. So let's go a little further out. What's the MJO going to do 2 weeks from now? Right? So this is outgoing long wave radiation forecast chart, 5-day increments. See out 5 days, 10 days, 15 days. South America, Central America there, the equator running right across there. There's Australia, New Guinea. Okay. Kelvin wave generation area, West Pacific, the area we're right interested in is right in here. And this shows literally no MJO signal, none 5 days from now, 10 days from now, sort of this mix. This is more sunlight reflectivity off the ocean surface, meaning the inactive phase. This is less sunlight reflectivity, meaning the active phase. But in the Kelvin wave generation area, just sort of more of the same. This per the statistic model. So basically, no real MJO signal forecast for the next 2 weeks. The dynamic model, a little bit less favorable, suggesting the inactive phase of the MJO building the West Pacific 10 to 15 days out. But even at that, not very strong. Phase diagram charts, another way of looking at the MJO very specifically. All right, so how do you read this chart? It looks kind of weird, but the MJO runs around the outside of the chart from west to east, from the Indian Ocean, over the Maritime Continent, over the West Pacific, East Pacific, under the United States. Remember, this is on the equator only. Under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. So both the active and inactive phase follow this path on the equator. The heavy dot is where the active phase is. And you're going, well, where is that? Oh, and the other thing is, so this circle, assume you're looking down on the North Pole, right? So, and the the closer the circle is to, or the closer the heavy dot, which is where the active phase is to this circle, the weaker it is. And it's normally considered weak if it's like here. But when you're inside the circle, it's all but non-existent. And this is the forecast track here. Basically, no change per the statistic model. The dynamic model suggests the active phase 15 days from now is to build some, but only out like in the west, what would that be? The western maritime continent, almost, Bali, that area. So of no use to us. We want the active phase somewhere here in the West Pacific. So we're not seeing any hope from these charts. Next, we go out 1 month. All right. And again, whole planet on one chart. There's the date line right there. Kelvin wave generation area starts from about here up like that to about here. Same picture. You see the blues just in control. Easterly anomalies. So that contour right there, the solid contour, is the active phase of the MJO. See the dotted contour back here in November? That was the inactive phase. And then here was another active phase back in like Halloween type time frame. But this active phase, all but gone, very weak, doing nothing. But you do see easterly anomalies, these blues in control and forecast to build very strong 1 week to about 2 weeks out from now, and then starting to fade. This is all, and the purple dotted line. In fact, here you go. Low, purple. That's the low pass filter. When it's dotted, that suggests a high pressure bias over the West Pacific here, and that is the hallmark of La Nina. Okay, and you also see the solid contour, the low pressure bias in the Indian Ocean. So again, another sign of La Nina. What we really want is this solid contour to be over the Pacific, but that isn't happening anytime soon because La Nina is fully in control of the Pacific. But as we can plainly see, based on what we looked at in the models, just because you're in La Nina, just because there is no active phase of the MJO doesn't mean that there can't be storms and there can't be surf. But what we have noticed is the storm track is pushed a bit to the north more than normal. And we also know that this season started incredibly slow. And we also know that when you do get windows of opportunity for storm production, they happen in small windows. You got to make the most of it. And then they disappear for a while. So the suggestion from all this is we're getting a window of opportunity for the next week or so. Make the most of it. And then one more MJO model going out 3 months. CFS model, CFS version 2 goes out 3 months. Past activity is down here, and just eyeballing it, there's the date line right there. Kelvin wave generation area goes straight up the chart like this. You can see we've had a lot of blues, a lot of easterly anomalies, the sign of La Nina, and forecast peaking like in a day from now and non-stop solid into pretty much the whole month of January. This would suggest no active phase of the MJO. And then look at this, as we get into February, supposedly an active phase builds with strong westerly anomalies. That would be good if it happens. Let's overlay the MJO. Here we go. It's just barely on the chart. All right, now look at this. Theoretically, we are in some sort of weak active phase right now. It's supposed to stall. Not even an inactive phase builds from it. And then a broader active phase sets up after that, setting up a big target somewhere from February 5th into about March 9th or something like that in the Kelvin wave generation area for storm production. That would be interesting if it materializes. But we also know that right here, with literally nothing going on, we're going to get storms. So, take this maybe with a grain of salt. And then after that, as we get into, we'll say March 1st or so, inactive phase, strong inactive phase sets up, easterly anomalies reappear. Now, part 2, don't believe a model even a week out, much less 2 or 3 months out. This model has consistently been showing these big, lumbering active phases showing up a month and a half to 2 months out. And this was one of those. and you see what actually happened. It's not the forecast. It's what's actually happening that matters. And it ended up being this one contour, nothing of an event. So we suspect that's probably what's going to happen here too as well. All right, overlay the low pass filter. And this really tells the story plain as day. Dotted contour again. The high pressure bias in control. There's the date line right down the middle. It is at 1, 2, 3 contours, forecast to build to 4 contours about January 10th, holding through March 1st. Okay, what we want in the Pacific isn't in the Pacific, it's in the Indian Ocean, the solid contour, the low pressure bias, and it looks like it's supposed to be peaking in the January, February time frame. We're hoping this would be the peak of La Nina, but we're also kind of hoping that maybe it's already peaked, and this is, atmospherically it's showing that signal, but typically, when your La Nina thing in the ocean, and that's what really matters, it peaks in the late November, early December time frame. So we'll get more into that in a second. So enough of the MJO thing. Let's go talk about La Nina or El Nino. Okay, and the first area we're looking at is ocean, but not at the surface, at depth. All right, so this is the East Pacific here. This is the West Pacific here. Notice this is going down in depth, down. Really what we're interested in is about the top 150 meters of the ocean. See these little lines and the X's? These are the anchor lines on the TAA buoy array, and the X's are the sensors on those lines. You take those readings, send it to our central processing facility, overlay it, use a model to fill in the gaps, and you get a profile of the subsurface ocean temperatures. Actual temperatures, we see 29 degree centigrade in the West Pacific. That's warm water. The 24 degree isotherm is at 175. That's about where it was last week, pretty much unchanged. The 24 degree isotherm is building to the east some at 120 west, suggesting that warm water is making a little bit of a try to back build to the east, meaning that trades above it have probably backed off a little bit, allowing the warm water not to slosh to the east, but at least to sort of trickle to the east a little bit. And it's anomalies, differences from normal for this time of year. That said, temperatures are still well below normal in the East Pacific. 2 degrees centigrade, that's maybe 3 plus degrees Fahrenheit. The entire Eastern Pacific, where's the date line at? Right there. Okay, so we'll go down. There's the date line. So we'll say 170, 160. So from Hawaii the whole way to Ecuador, colder than normal water temperatures. That sort of stomps on evaporation, right? If the ocean's colder, it doesn't evaporate. Water doesn't evaporate from it. The evaporation is what imparts energy to the jet stream, and it helps make storms and all that kind of stuff. Even down on the equator, warm water balled up, locked at about 160 west in the far West Pacific. Another model using the same data paints the same picture. The interesting part, though, let's do this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 4 to 5 degrees below normal in this pocket here. But, this doesn't look as cold as what it did a month ago or 2 months ago. It's still cold, filling the entire East Pacific into the West Pacific, but also notice a lot of warm water building here in the West Pacific, and that's exactly what you want to see. The longer La Nina goes, the more warm water gets balled up here in the West Pacific because easterly trades are nuking during La Nina, preventing Kelvin waves from developing, but at some point, all this warm water, it's going to reach a breaking point. As soon as the trades back off a little bit, it's all just going to go whoosh and swash off to the east, and that theoretically could be the kickoff to El Nino, and we all know that El Nino is great for storm and surf production in the Pacific Ocean. Quick look at sea level anomalies. What is this? So there is South America, Central America, Mexico. This is the equator. That's the date line. There's New Guinea there. We're looking at the height of the ocean, and that is assuming no waves, take them out, take the wind waves out, take the tides out, and assuming the Earth is more or less a perfect sphere, then how high is the ocean compared to normal? And we see 10, minus 10, minus 15, minus 20 degrees, and it's really just on the minus 20 centimeters, below normal. What's that mean? Well, if you have cold water at depth, it contracts. That in turn creates a divot on the ocean surface. Jason-3 satellite can measure that, and this is the reflection of that. So all this does is confirm that you have a massive triangle of cold water from Chile out to the intersection of the dateline and the equator, the whole way up into, the whole way up into Northern California, just in control, all driven by strong easterly trades on the equator that's causing upwelling and causing cold temperatures, and that all is the hallmark of La Nina. One other chart, this is the upper ocean heat anomalies over time, right? So you get a sort of a historical perspective going back a year, January 2020. You can see warm water, the yellows and oranges are warm water. They were, this is literally a Kelvin wave. The last Kelvin wave we saw was March of 2020, and then since then there's been cold water in control, easterly anomalies, trade stronger than normal. This is what we think was the peak of La Nina, right here around the Halloween time frame. Notice that the temperature profile is warmed slightly. The concentration of the cool anomalies not as strong as they were. Also notice the building warm signature. Look at that right there in the far West Pacific. Not suggesting that El Nino is anywhere near coming, but the underpinnings for an El Nino development at some point in the future, maybe a year from now, are there. But what we're really more interested in is, are we at the peak of La Nina? And we think that that's already passed. We have, another 2 or 3 weeks of strong easterly anomalies forecast, and then after that, if this sort of thing doesn't reappear down here, then maybe we're past the peak and moving into the demise of La Nina. But that's just speculation at this early date. All right, let's make a quick look now at the ocean surface. I mean, if it's cold and upwelling deep in the ocean at the surface, one would expect the same thing, and that's exactly what we're seeing. Here's South America here, Peru right in this region, Central America, Mexico, you get the idea. The equator is right here. You see the blues, much colder than normal temperatures, filling the whole coast of Chile, Peru, over the Galapagos, the whole way out to the dateline. But the density of these cold anomalies is much less than it was. We do have this new little pocket of cooling developing here, presumably associated with strong easterly winds there. And cool anomalies here even look like they're starting to fade a little bit. Now, that doesn't mean they're getting warm. They're just not as cold as they were. And again, that sort of gets us to that point of we think La Nina might be past its peak. Here's the 7-day trend on this chart, just 7 days. You see warming is actually going on off of Chile and Peru. Yes, we have some colding. Oh, look at that. The cooling is occurring here just off of Ecuador and off the Galapagos, and we saw a little bit of pocket of cool temperatures building there. So not surprising, but all in all, it appears that we're moving in a warming trend, at least for the short term. If we can get through the next 2 to 3 weeks, maybe 4 weeks, with this not turning ravagingly dark blue, then that would be a clear sign that we're past the peak of La Nina. The overview again, now here is right where that cooling trend was seen. You can see a little bit of that in the anomaly chart here. But overall, all this cooling in here, much less dense, much less concentrated than it's been for weeks and months. So that's giving us a little bit of a smile. The sea surface temperature trend in the Nino 1.2 region is the area right up there along Peru and the Galapagos. The temperature trend started downward around December 13th. Today we are at minus 1.373 degrees, so that's certainly not warm. But this is not the official El Nino monitoring region. Still, it sort of gives you a hint of kind of what's going on. This is a noisy area, and you can see it jumps around a lot. And we thought we were kind of on a warming trend here, but this is sort of giving us some pause. If it doesn't get any colder than this, that'd be okay. But with we know a bunch of easterly anomalies are coming, and we suspect those temperatures are going to drop even more. The official El Nino monitoring region, the Nino 3.4 region, rock steady as it has been, well, maybe going up a little bit, really since November 15th, minus 1.047. That is indicative of a moderate La Nina. This La Nina was at one point forecast to go down to minus 2.5 degrees. That would have been extremely strong. If we stay here, yes, it's horrible. It's not great. It's not what we want, but, it could be a lot worse. And then finally, what does the atmosphere? We've talked down in the ocean. We've talked at the ocean surface. Now we're going to look at the atmosphere above the ocean, and what does the atmosphere think is going on? So we use the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. There's like 150 years worth of data there or something. Daily indexes. When the index is positive, that means there's higher pressure over Tahiti, which means higher pressure over the Pacific, at least in the equatorial regions. And today's contribution, plus 15.15, and you can just sort of scan down here, see, we were up at 35 there. Pretty high. Not nary a sign of negative numbers. If you were in the active phase of the MJO, these numbers theoretically should be negative. Nowhere close to that. 30-day average takes some of the noise out, still quite high. Plus 15.72, clearly a sign of La Nina. The 90-day average, very much a 3-month lagging indicator, but even that's at 9.54, and we can go down and see, we were at 7.6 a month ago, and now we're up to 9.54. All this is suggesting is La Nina is in control. The MJO, active phase of the MJO, nowhere to be seen. Pure La Nina state in control. Here's a graph of the 30-day moving SOI average. It's saying the same picture. You can see negative is El Nino, positive is La Nina. La Nina, not good, not favorable for storm production in most cases. You see the trend steadily upward. We're on a roll today, way up here, the 30-day average above 15, and likely going to continue upwards. So you go, the peak of La Nina, if it was reached in November in the ocean, why is this still going on? Well, the atmosphere lags behind the ocean in some cases. The atmosphere and the ocean are getting coupled. The ocean peaked in its La Nina, we are hoping, cold temperature configuration. Now the atmosphere is catching up and responding in kind. And then finally, the official Nino 3.4 sea surface temperature anomaly forecast from the CFS version 2 model. All right, here's where we are today, or it will say late December. Temperatures right 1 degree below normal, certainly moderate La Nina. But then you look at the forecast, it goes, we're supposed to hold into, the line here is mid-January, maybe through the month of January, and then a steady upward trend, and moving out of La Nina territory as we get into, let's say, early April, and then recovering to maybe minus 0.3 of a degree below normal and plateauing there. This would be great. No sign of El Nino developing, certainly not this year. La Nina is well entrenched both in the ocean, in the atmosphere. We all know that. We saw this coming. The hope would be that as we get into next fall, that this La Nina thing just dies. We return to normal. And then maybe February, a year from now, we maybe start approaching some sort of El Nino pattern. Certainly, all the warm water buildup in the West Pacific, at some point the dam's going to break on that, but right now it's just starting to build. So though we are in La Nina, clearly that doesn't mean that you can't get storms, because there's a lot of activity going on right now. Jet stream looks great. A whole series of storms forecast to push across the North Pacific in the next week. Precipitation into California, and maybe a fairly good amount if you believe the GFS model going 10 days out. Don't believe that, but we'll see. All precipitation is welcome and good. But right now, we're in a sweet spot, irrespective of the MJO situation, irrespective of anything. There is waves coming. It looks that way, and hopefully we'll get some good conditions, so make the most of it. All right, if you enjoyed the video, give us a thumbs up. We'd appreciate it. There you go. There's your thumbs up. If you haven't subscribed, please subscribe. Comments are always welcome. Yes, we're a bit backlogged. There's a bunch of comments from last week's video. We're also trying to have a little bit of a Christmas holiday, New Year's holiday, but we'll pick at it here and there and try to get to it. Normally, we try to be right on top of it, but we're lagging a little bit, so sorry about that. So subscribe, interact with us if you like. Questions, good questions, just post them on the comment section, and we will do our best to get to you. All right, so that's it for this week. We'll do this next week, hopefully, if we don't get sidetracked by surf and a bunch of other stuff. Next week, same time, same channel. Thank you for watching. Merry Christmas and Happy New Year. Be safe, but get some surf. All right, goodbye.